Okay, so I know that most of you will know how to do this, but we're gonna do an example or two on the board here. I guess I need the other B in there. Probability. Now, we're going to do some simple questions, and Mrs. Myden will be able to help you on this. We'll just get into it. What is probability? Well, it's the chance of an event occurring. Real simple. So, is it 1 in 2? Is it a 25% chance? All that kind of stuff. And we can show it a number of ways. We can show it as a fraction. Or better yet, some people say that's a ratio. That's another way of showing it. We can show probability as a decimal as well. And some people would say, well, that's a percentage. So, 0.25 or 25%, that kind of thing. Well, let's really quickly write an example down. A soccer team goes into overtime. 10 out of 84 regular season games. Okay, so there's the statement. A soccer team goes into overtime 10 out of 84 regular season games. I'll put the questions in red. A, what is the probability of the team going into overtime? So what is the probability of that occurring? B, if the team plays 16 playoff games, what, I guess not what, but how many games can we expect to go into overtime? So how many games out of the playoffs, if they only play 16 games, how many might go into overtime? And C, real quick, let's just explain if the probabilities are the same during the regular season and playoffs. So, explain. Just tell me. What do you think? Do you think the probability should be the same? Should it be different? Why? That kind of stuff. So when we go and do this part now, the probability, I gotta erase the board here. The probability of a game going into overtime, well, if we look at the question, it does say 11 games go into overtime. Oh, sorry, not 11, 10. My bad. 10 games out of 84. Well, that might be an okay way of writing it, but I see that we can reduce this fraction, so this probability. It actually, if I divided a 2 out of both those numbers, I would get 5 out of 42. Now, that's perfectly okay to say the probability is 5 out of 42. So this team may have 5 games going to overtime out of 42. Or we could actually divide those numbers and get a decimal like 0.119 when we divide 5 divided by 42, or that 0.119 is actually 11.9%, because if we times that by 100 to turn it into a percentage. So these are also legitimate ways of writing it. I guess as a ratio, we could actually put it 5 out of 5 in terms of a ratio, 5:42 and that kind of stuff as well. But that we'll save that for another time. Question B. Well, we're going to use this probability for question B. I know we've got a C question that asks us whether they should be the same, but we don't know anything different yet. So we're going to say 16 games they play in overtime. And the chance of them going into overtime is 11.9%, or 0.119. When we do that out, we get 1.9 games when we throw that into our calculator. And make that clear enough. It's decimal 119 that we're multiplying by. Well, we can't have 1.9 games. That's kind of impossible. But we can have 2 games when we round it. Okay, so there's how many games we can expect to go into overtime. But question C asks us to explain whether these should be the same or not, these probabilities in regular season versus the playoffs. Well, I would say no. This is me personally. You can excuse me, explain it however you want, but I would say no. I expect more games. More games, or a higher percentage to go into overtime, because the teams should be more evenly matched. It's playoffs, right? All the bad teams didn't make it, so these are all the top 16 teams. Who knows? Or maybe it's not 16 teams. Maybe it's 8 teams. Maybe it's 4 teams. I mean, who knows what sport we're talking about? But I hope you see how easy that is, and we'll move on to the next example here.